Hello and welcome. So far, we have discussed what is the work breakdown structure. We identified the tasks and we understood how to identify the tasks. And then we understood that we can have relationship between the tasks and we need to form a logic based on which the tasks will be associated to each other. Now, based on that primer, let us try to create the project network that can become a plan which can be executed. So in this video, we will go through the process of how to create the project schedule network. Before we start creating the network, let us just have a convention for ourselves. Now, different books and different people will use different conventions. So I am just proposing something. You can also create your own convention. That is not a very big problem. Now here, I will represent a rectangle as the activity. Now the activity will have a name which I will state here at this place. So A is the name of the activity of this particular uh, rectangle that I have represented. Now every activity needs to have a duration, that is the time it will take to conduct that activity. So we will represent the duration in this orange circle where I will write the number. The 12 here means that this activity is going to take 12 days time. Then I will introduce some terms to you which will become clear as we go on the discussion on creating the network. Anyway, I will introduce them right now. The first term is early start. Early start basically means the time or the point in the project when this particular task A can begin at the earliest. It is not possible to begin this task before this particular date, that is the early start date. Then we have early finish. Early finish is the date when the activity can finish if the activity starts on the early start. So the early finish can be calculated as early finish is equal to early start plus the duration minus 1. So because we count 18 also in this case as the day on which the activity will be performed. So we can get the early finish by this calculation where we say early finish is equal to early start plus duration minus 1. Then on the bottom we see that we have two more terms, late start and late finish. Now late start is a date on which the activity can start at the latest, that is the last date on which the activity should start is known as a late start. And if the activity starts on the late start date, what is the date on which the activity will finish is the activity's late finish. So the late start can be calculated as late start is equal to late finish minus the duration plus 1. So this is the formula we can use for calculating the late start. Once we have all these numbers with us, we can calculate what we know as the slack or the float. Float is a period of time by which we can delay a particular activity. So this can be calculated as late finish minus early finish, or we can also calculate it as late start minus early start. So with this background, let us start building our network. So I will just copy this and go on to a blank sheet. So here I have planted for you one project estimate and plan that we will try to create a network for. So here I have the tasks. There are 12 tasks. Each task has got a duration, and I have identified what are the predecessors for each task. So now let's start building our network. So I will put my first activity on the network. So this is my activity A. In my plan, I see that activity A will take a duration of 7 days. So let me change the duration to 7. Now activity A has no predecessor, so it is the starting point of our project. So this activity should start on day 1. If this activity starts on day 1, this activity should finish on 1 plus 7 minus 1, that is on the 7th day of the project. So let us just have this. Let me just remove this late start and late finish for the moment. So we have done the first job for activity A. So activity A starts on day 1 and finishes on day 7. Now let's try to create the activity B. So I will create this new activity called activity B. We notice that activity B is scheduled to take 11 days. So I change the duration to 11. Now activity B has a predecessor in activity A. So I must make a relationship that, let us assume for the moment that all relationships are finished to start relationships. So activity B starts after activity A finishes. So activity B's early start should be 7 plus 1, 8. That is, on the day activity A finishes, the next day activity B should start. So now we can calculate the early finish of activity B, that is 8 plus 11, that is 19, minus 1, that is 18. Now let us go for activity C. So I put one other activity here. This is activity C. Now activity C also has a predecessor in A and it takes 12 days. So I make the duration as 12 and I make a predecessor from A to C. Now since activity C has to start after activity A, it can start on the 8th day because activity A finishes on the 7th day, and the early finish will be 8 plus 12, 20, minus 1, that is 19. Right. Next we see that we have activity D, which has got two predecessors, B and C. So activity D can start after activity B and C have finished. So I put my activity D here. I notice that it takes 6 days. So I will put the duration as 6. Now activity D can start only after activity B and C both have completed. So we need to see which activity finishes last in among activity B and C. That activity C finishes on 19th day and activity B finishes on 18th day. So activity D can start only on the 20th day. So I put 20 as the early start. I can now calculate the early finish of activity D. 20 plus 6, 26, minus 1, 25. Next, we see that activity C has a predecessor in activity D and it takes 8 days. So now let's make the relationship for activity D. So there we have it. So next we plant activity E, which is the next task after activity D. So I put it here. So this is my activity E. Its duration is 8 days. Now the linkage, let us make it. So D to E. Now activity D finishes on 25th day. So activity E can only start on the 26th day. And it is 8 days duration. So 26 plus 8 is 34, minus 1, 33. Next we go to activity F, which follows activity E. So now let us make activity F. Activity F takes 11 days. So now let's make it as 11 and we connect the two activities. Now activity F can start on the 34th day because activity E finishes on the 33rd day. So 34, the 34 plus 11 is 45, minus 1, 44. So activity F's early finish is 44th day. Next we go to activity G, which follows activity F and it takes 9 days duration. So I create activity G now. So this is my activity G. It takes 9 days. Since it is following activity F, it can start on 45th day at the earliest, and 45 plus 9 is 54, minus 1, 53. So early finish is 53. Next, we go to activity H. Now we see that activity H is following activity G, but however, activity I also follows activity G. So we have two activities after activity G, that is H and I. So I just place it here. Okay, there we have it. So this is activity H, and it takes 9 days, so that is okay. And it follows activity G. So I put it like this. And G finishes on 53rd day, so this has to start on 54th day. 54. Okay. Now the early finish will be 54 plus 963 minus 162. Now let's go for activity I. Activity I also follows activity G. So I need to place it here. Okay. This is our activity I. It takes 8 days. So I change the duration. 8 days. Now it follows activity G. So the early start will be the same as activity H, that is 54. However, the early finish will now be 61. Next, we have activity J, which follows activity H and I. So I will create activity J. To follow activity H and I. This is my activity J. Activity J takes 8 days, so we have that. So the early start will be the one which is greatest of the end date of activity H and I, that is 62 plus 163. So the first, let's make the link. So this will be 63. 63 plus 8 is 71 minus 170. Next we go for activity K. Activity K. It takes 9 days. It follows activity J. So this should start on the 71st day. And 71 plus 9 is 80 minus 179. So there we have activity K also. Last we have activity L, which follows activity K. So I create activity L. Activity L takes 3 days. So it would start on the 80th day. 80 plus 3, 83 minus 1, 82. So this is the early finish of activity L. So we have calculated the total duration of the project, assuming that we start on the first day and we carry on the activities in the earliest possible time which is possible to execute the activities. What we have done basically is that we have executed the forward pass. So what we have done is basically we have done the forward pass. So in forward pass, we calculated the early start and early finish of all the activities. Now once we have the early start and early finish of all the activities, we know that this particular project will take 82 days. I consider that, supposing this project takes 82 days and I start calculating backwards. Now, if this project takes 82 days, I consider that activity L's late finish is 82. So from the late finish of activity L, I can calculate the late start of activity L. That is 82 minus 3, 79 plus 1, 80. So this is the late start of activity L. Now, if activity L starts on 80th day, then activity K should finish one day before that. So it should be 79. So late finish of activity K will be 79. The late start can be calculated as 79 minus 9, 70 plus 1, that is 71. We can similarly calculate the late finish of activity J, which will be 70 minus 1, 70. And the late start will be 70 minus 8, 62 plus 1, 63. Now we have to calculate the late finish of activity H and activity I. So both activity H and activity I have to finish one day before activity J. So their late finish will be 63 minus 1, 62. 63 minus 1, 62. However, now let's calculate the late start of activity I. So the activity I's late start will be 62 minus 8, that is 54 plus 1, 55. 55. And the late start of activity H will be 62 minus 9, that is 53 plus 1, 54. So we notice that there is activity I, the late start and the early start are not the same, and so there is a slack here. And other activities so far, they did not have any slack. We will discuss that slightly later. Now we come to activity G. What needs to be the late finish of activity G? Activity G's late finish should be the minimum of the late starts of activity H and I, because activity G should finish before either activity H or activity I can start. So we take the minimum from activity H and activity I, that is 54, and then subtract 1, so we get 53. So once we get 53, the early finish, the late start can be calculated as 53 minus 9 plus 1, that is 45. This is straightforward. Activity F must finish one day before activity G's late start. So this is 44. And we know already how to calculate late start. So this will be 34. Similarly, we calculate for activity E. This will be 33 and this will be 26. I also calculate for activity D. This will be 25 and the late start will be 20. Now we come to activity C and activity B. So activity C has to finish one day before activity D. That is, it has to finish on the 19th day. The same applies for activity B also. It has to finish on 19th day. Now activity B, if it finishes 19th day, it has to start on 19 minus 11, that is 8 plus 1 on the 9th day. The activity C has to finish on the 19th day, so its late start will be 19 minus 12, that is 7 plus 1, 8. Again, we come to the place where we have activity A, which has to finish before both activity B and C. So we take the minimum of activity B and C's late start and subtract 1. So I get 8 minus 1, that is 7. And if activity finishes on 7th day, late finish, the late start can be 7 minus 7 plus 1, that is equal to 1. So now we have calculated the late start and late finish. So what we basically did was, this is known as the backward pass. So we have conducted the backward pass of our network. So now you see we have got our network. On this network, we notice that we have got this activity B, which has got a slack of 1, and we have got this activity I, which has got a slack of 1. Now all the remaining activities do not have any slack. Now let's start from A and try to traverse our network. So if I go from A has no slack. So A has to start and finish in the same day. No matter whether we start early or we start late. The same applies for activity C also. So I will just color this in a different color, and we will see what it implies. Then you notice that after activity C, activity D also, the late start and the late finish and the early start and early finish are the same day. So I color this in this different color. The same, now we go ahead and find the same thing for activity E, F, G. Now activity H, the late start and early start are the same. So I color this also, and same from activity H to J. If I go J, the early start and late start are the same. So I color this, and these are also the same. So you notice that I have got a path which goes from the first activity in my network, that is activity A, till the last activity in the network, that is activity L. So this path, on this path, all the activities have got the same early start and early finish, and the same same late start and late finish. That is, you notice that late start minus early start is equal to the slack. So if I calculate late start minus early start for all these activities which I have painted on the orange arrow, it is 0. So when an activity has 0 slack, so we call that activity is on the critical path. So this path, this orange color path that we have traversed from the start of the project till the end of the project, is known as the critical path. So critical path is the path on which none of the activities can be delayed. So if I delay any activity on the critical path, then my whole project will get delayed. So with this, we come to the conclusion of our discussion of how to create the project network.